Hey guys, this is video 4, design. Okay, so all these questions have to do with how we go about designing it, just so that if we did a study, if it's designed well, then we can use the data. Okay, so the first question says, town council wants to estimate the proportion of all adults in this medium-sized town who favor the tax increase. So it doesn't say all registered or all voting adults, it says all. So that means we can't take it out of the local phone book. We can't just do the local schools. We can't do an online survey. We can't just talk to the homeowners. We have to talk to all of them. So the last one would be the only way to really be able to make an inference about the population, because in that list, everyone had an equal chance of being chosen because it was an all-inclusive list. All right, the next question that had to do with design was question number 20, so let's take a look. Random assignment is part of a well-designed comparative experiment because, okay, so we're going to have a couple examples of this, but it should make sense. Like, let's say I was going to have 40 people, and it's an experiment because I'm going to make them take a pill. And I'm going to make them take the old pill to see if it works, and then the new pill, another group of 20. Take the new pill. So I have to have random assignment here, or else, that's going to mess everything up. So it creates two groups that are roughly equivalent, so that each group should be like a little half of a population of people in general. And that's why we have to use random assignment. All right, we like it. Question number 23 says, which sampling method was used in each of the following settings in order from 1 to 4? Okay, so in the first one, we have a student chooses the very first 20 students you get to sort. But that was very convenient of you, right? So this is called an convenience because you just took the first ones you came by. Name of each student in school is written on a card. The card is well mixed and 10 names are drawn. That would be an example of a simple random sample. It was simple. Everyone had an equal chance of being chosen, so that's an SRS. So we're already kind of eliminating now. Maybe you were able to kind of narrow this one down to B or D. Okay. A state agency randomly selects 50 people from each of the state's senatorial districts. Okay, so they're figuring at the district from each district. So let's say you have a District 1, a District 2. This is like in track or any kind of a sport. We each have a district that we run in. And the top 4 competitors were able in that district. So that is, but it wasn't random, right? But if we think about that, in this example, they took 50 from each district. So these are strata. So this is a stratified random sample because each of those would be considered strata. Okay, that leaves this as a cluster, but let's go ahead and read it. A city council randomly selects 8 city blocks and then surveys everyone in that block. Yeah, that's a cluster. So again, it maps it out. It randomly selects. Right. Think about the whole map. It randomly picks 8. So maybe it randomly selects 8, and then everybody in that block gets sampled. That is a cluster sample. Okay, question number 30 has to do with design. Let's take a look. It says, an experimenter wishes to test one of the 2 types of fish food. So we start out with our 40, and we need to have them test the old fish food and this new product, right? The experimenter has 2 identical fish tanks. Okay, so we can't fit them all in a fish tank. So This tells us that we want to match these as best as we can. Okay. So that means I can't have a twin fish. There's no such thing. I can't decide if one fish is a twin. So I'm going to try to match fish. Maybe this one's a little bit bigger, and I'll find one almost the same size, and I want to put that one, if I find a twin, put one in tank A and one in tank B, if that makes sense. So that we're creating kind of a match pair that tank A looks like it has all the same type of fish, and tank B looks like it has all a good variation of sizes, okay? So that's what we would do here, is that you would put 20 fish of varying sizes in your tank. I said tank A, but it says tank 1. And 20 fish of varying sizes in tank 2. And we set up this match pair. And then that way we can compare this fish to that fish at the end. Okay, so which one describes this setup? When we take a look here, it looks like B. Yeah, obtain pairs of fish who weigh roughly the same, and then randomly assign one of the pairs to tank 1 and one of the pairs to tank 2. So it's almost having your twin brother go to one tank, go to the other. Everybody in tank 1 gets the same old food. Everybody in tank 2 gets the new food. This is our best strategy for being able to see if the tanks, if the new food has a better result, or, you know, it gets heavier fish. All right. And again, this is a matched pair example where we call it, its blocking size is 2. This is technically a block of 2 fish that are as close to twins as possible. All right, the last question in this question set type is 35. So let's dig in. It says a clinical trial of 30 patients. Were randomly assigned 2 groups. One of the groups was assigned the marketed medicine. The other group got the experimental medicine. Every week, patients reported back to the blood test. The clinic technician was unaware, and the patient itself was unaware. So this is considered a double blind. So I like A. Let's see if my other choices present any double blind. Okay, yep. Double blind, double blind, double blind. So let's keep digging. We had our 30 patients. They were randomly assigned to the 2 groups. Right? And that's it. So they didn't do any type of match pair or anything like that. So it looks like this is just a completely randomized experiment with the currently marketed medicine and the experimental medicine as the 2 treatments. So everybody in group 1 got treatment, got the old treatment, and everybody in group 2 got the new treatment. Okay. Now let's look at the other ones. It looks like A is our answer, but let's dig a little deeper. A matched pair. It doesn't look like we did that. Would be nice. Block design. Block design would be, well, a matched pair of 2, but a block design, maybe we separated men and women. They didn't say they did that either. Randomized observational. No, it's not observational because we gave them a pill. So this has to be an experiment because we gave them a treatment. There was a treatment. Okay. So we're definitely picking A. And that is the last question in this section, design.